Okay, before we get into this problem, I want to point out that there is a misprint that we should talk about. So here, this should be 7, and this should be 72. This will make things work out a lot nicer, and we all want to have things that work out nicer. So now let's get into the problem. A rectangle has a length of 7 meters more than twice the width. Find all of the possible widths that result in an area of the rectangle not exceeding 72 square meters. Right? There's a lot of information in here. We're going to pull it apart a little bit at a time. All right? So first off, a rectangle, we all know how that looks like, right? We've got length, we have width, right? So we've got length and width, and our area is equal to length times width. Right? So that's just basic things that we know about rectangles, right? Now, we know that the rectangle has a length 7 meters more than twice the width. That means that our length is equal to twice the width plus 7, right? And that also means that area is equal to length times width, which means it's equal to 2 times W plus 7, because that's what our area is, or our length is equal to, right? We can just substitute that in, and this is times W, right? So we're just putting this equation and this equation together right here, right? And that last bit of information that we got here said that the area is not exceeding 72 square meters. That means that this area here has to be less than or equal to 72. Right? So now we've got a quadratic inequality, and we know how to solve these. Right? So let's keep rolling here. All right, I'm going to multiply this out. So I'm going to have 2w squared plus 7w is less than or equal to 72. Right? I'm going to pull this over to this side. That'll give me 2w squared plus 7w minus 72 is less than or equal to 0. That is something that we've been looking at. All right, so now we want to factor this. All right, that's going to get a little crazy, so let's set up our box. All right, so we have 2w squared, and we have negative 72. We're going to cross multiply these. That is going to give us, let's see, 144 w squared negative. And we need things that multiply together to give us that, and add together to give us 7w. And something I should have pointed out before I started factoring is that that means we're going to have different signs. Right? So negative 144. Eesh, that's going to be a lot. That's all right. The other thing we can do is guess and check, but we'll get to that. Right. So we've got 1 and 144. Not really helpful. 2 and what? 72. That's nowhere near 7. So 3 doesn't go into it. 4 doesn't go into it. No, it does. 4 would go into it. What? 30. 36 times. Still not close. 5 doesn't. 6 goes into it. 24 times. Also still not close to that 7. Right. So 8 goes in 18 times. 9 goes in 16 times. This is good. So 9 and 16 are 7 apart. So now we just need to have a positive 7 and a negative 62. So one of these has to be negative. Because we're coming out with a positive number, it's going to have to be the smaller one. right? So we'll have a negative 9 and a positive 16. So let's put these in. Negative 9w, 16w. So here, our GCF is going to be w. Here, our GCF is going to be 8. Here, we're going to have 2w. And here, we will have negative 9. So this factors as 2w minus 9 times w plus 8, less than or equal to 0. And let's just double check ourselves. So here we'll have a minus 9w. Here we will have 16w. And then sure enough, negative 9 plus 16 will give us that 7w. So we have factored correctly. When in doubt, always check. All right. So now I need to find out where we're going to have our positive and negative intervals. So we will have 2w minus 9 and w plus 8. We're going to have our number lines. Negative infinity to infinity. Right. This is going to equal 0, and 2w minus 9 equals 0. And if you need to do this off to the side, that's fine. That means that 2w is equal to 9, or w is equal to 9 over 2. Over here, w plus 8 equals 0 means that w is equal to negative 8. Right? Negative 8 is a smaller number, so we're going to put that here, break up our number line, and then we'll have 9 over 2. I'll break that up here. So in between negative infinity and negative 8, right, we are going to have, let's do all of our signs first. All right, so for 2w minus 9, right, if we are less than 9 over 2, say if we're at 0, this is going to be negative. So we will have a negative, negative. If we are greater than 9 over 2, let's say we're at 20, 40 minus 9 will be positive. For w plus 8, if we are less than negative 8, let's say we're at negative 10, negative 10 plus 8, that is going to give me a negative 2, which is negative. Something greater than negative 8, 0. 0 plus 8 is 8, that's positive. Okay, so now coming back to this interval between negative infinity and negative 8, we have a negative times a negative. That is going to give us a positive. Between negative 8 and 9 over 2, we're going to have a negative times a positive. That is going to give us a negative. And between 9 over 2 and infinity, we are going to have a positive times a positive. That'll give us a positive. Coming back over here, we are looking for less than or equal to. Between negative infinity and negative 8, we have a positive that is not less than or equal to. It is not part of our solution. We don't want it. Between negative 8 and 9 over 2, we have a negative that is less than 0. That is part of our solution. We're going to keep it. Between 9 over 2 and infinity, we have a positive number that is not less than 0. It is not part of our solution. Okay? So our solution is going to be the interval from negative 8 to 9 over 2. And this is less than or equal to, so we would be including those boundaries. Right? Now we have to go back and say this is a word problem. Word problems have word solutions and they have to make sense. We are looking for all possible widths that result in an area not exceeding 72 meters. All right, so if we're just looking at the numbers, our possible solutions are between negative 8 and 9 over 2. Well, that doesn't make any sense if we're talking about the length of a board. So what we would say, just a note to ourselves, width can't be negative. So our answer is the board can be up to 9/2 meters wide. So it's a complicated problem, it's a little bit messy, but that is exactly how you would solve it. Hope this helps.